Look at the Strait of Hormuz on a map. At its narrowest, this waterway is only 21 miles wide, yet it operates as the most heavily monitored maritime choke point on Earth. For decades, geopolitical analysts have treated this passage as a physical transport artery. They track the flow of oil destined to become fuel for cars, shipping logistics, and heating for homes. We have historical precedent for what happens when this specific supply line is threatened. The panic usually looks exactly like this: halted transportation, long lines at the pump, and domestic gas prices shooting up overnight. Analysts stuck in that transportation mindset are misreading current global strategy. In the exponential age, energy functions as the primary raw material for digital intelligence. To accurately map the modern AI conflict, we have to stop fixating on the physical paths of maritime oil tankers and start tracing the massive electrical grids those shipments ultimately power. The idea of artificial intelligence existing in a weightless, invisible cloud is an illusion. AI lives inside physical, hyperscale data centers packed with thousands of densely stocked server racks that never stop running. Keeping those processors operating and cool enough to prevent a meltdown draws an unfathomable amount of raw power straight from the industrial electrical grid. Think of fossil fuel imports as liquid batteries. Even if not burned directly at the server site, they provide the base load stability for the entire national grid that these data centers tap into. Because AI training is so energy intensive, it's the first thing sacrificed during a fuel shortage. To keep hospitals and homes powered, the state literally has to pull the plug on its compute capacity. This dynamic is driving a massive geopolitical split. China has a clear mandate to construct a completely independent AI hardware stack, relying on pristine, highly automated tech manufacturing facilities like this one to build their own processors. That sovereign strategy contains a geographic flaw. Chip fabrication relies on energy from the Strait of Hormuz. The US tries embargoes, but policing millions of tiny components moving through overlapping global supply chains is full of logistical loopholes. Manipulating a centralized geographic bottleneck requires far less effort. You don't need to intercept microscopic silicon parts if you can simply squeeze the main energy valve powering the factories that make them. The most effective asymmetric warfare strategy today relies entirely on exploiting a legacy vulnerability left over from the 20th century. Imagine a war room scenario where naval tension leads to a targeted military blockade or severe destabilization in the strait. The immediate economic reaction is a sharp spike in global energy costs, a shockwave that hits Asian industrial manufacturing with devastating precision. This chart shows the direct relationship between imported energy costs and AI development. As the energy line spikes upward, it triggers an immediate, exponential rise in the cost to train large AI models. The sheer volume of electricity required makes the training phase financially unviable during a supply crisis. It forces a strategic checkmate. The targeted nation has to divert billions in capital and years of labor away from AI innovation, dumping those resources into securing basic domestic energy independence just to keep the lights on. We have to stop measuring global power by the price of a physical barrel of oil. Whoever controls that fuel flow dictates how much a rival can compute and ultimately controls the global price of intellect.